So we're looking at the independent and dependent events, section 10.9. An independent event, two or more events in which the outcome does not affect the outcome of the other event or event. In a symbol, it's for the probability of A and B equals the probability A times the probability of B. Then we have a dependent event, two or more events in which the outcome does affect the outcome of the other events. And in symbols, it is the probability of A and B is the probability of A, and then the probability of B following the event A. Yeah. What I have there written in that beautiful handwriting, it says the number of chances left over the number of total left. Keyword being left.
That is a lovely handwriting.
Thank you. That lefty boy handwriting. I am left-handed.
Right-handeds are awesome.
Yeah.
You're supposed to write with your paper like in front of you, but everybody turns
Yeah, that's what I do.
Supposed to read
So here's the situation that we have. In a popular board game that will not be mentioned because it's copywritten, you go to jail if you roll 3 doubles in a row. What is the probability of rolling 3 doubles in a row? Well, first off, I'm going to tell you that this, because we're just learning it right now, the probability, or the events here, off the top of your head, do you think it's a dependent or independent situation? Dependent. We got some dependent. We got some independent. Huh. Now, one of the things that is... Do you need to move up a bit? One of the situations with a dependent variable situation, I said situation twice, is something changing? Is the first event changing when the second event happens? Okay. For example, if I were to do this. If I were to do this, I'm going to give a sucker to the random person's name that I draw in the discipline binder. Okay? It goes to... Okay, so Dominique gets a sucker. Okay? Okay, now, when I do the same thing, is it from the same group? Okay, I'm going to 7th period, going to pick a random person, you get a sucker. Is it the same thing? Okay. It is. It's still the same guys, right?
Oh, yeah, okay. I thought you meant like the same outcome.
Same. Well, okay, then I got Cam. Now, here's the situation. I'm going to close this. Now, here is... Would you agree that the both of those drawings were independent of each other? Okay, now I'm going to make it a dependent variable. This is how it changes. For the third person that I draw, as long as it's not these two, because they already won, they can't win twice. See the difference? Okay? It's different. The number of people who could win right now is now 17. It used to be 19, then it was 18, then it was 17. If I say, you two can't win again. Whoop. Whoop. Nope, just you 3.
What?
Yep. Okay. Okay. Yes, you may have it right now for those 3 lucky people. Okay. Do you see how it was different? Do you see how it was different? It was dependent on who won as far as the choices that's next. The second group of choices depended on what happened before it. Because if I would have gone to Cam or Dominique's name when I picked Max, that wouldn't count. They weren't part of the same group. The second one relied on people getting it before then. They could no longer win another one. Does that make sense? Okay, let's explore this some more. So we have to find the probability of getting doubles. Whoa. What am I doing? There. The probability of getting dubs. The doubles. Now, we did this probability before. Okay? We've done this probability before. Haven't we?
Yeah.
Let's see, how many times does it happen? Is this the page I'm looking for? This is not the page you're looking for. No, that's not it. That's not it. Yes. Yes. All right. How many doubles are there in here? And this is the table that we created last Tuesday after watching Bill Nye. So how many doubles are in here? There's 1, 2, 3, 4, 5, 6. There's 6 of them. 6 out of how many? There's 6 out of 36.
I thought it was 6 out of 40. Why did you put 40? Because, like, you have to go.
So we have, is this, nope.
You have to count those squares.
6. 6 out of 36, quiet please. 6 out of 36, which simplifies to what, Johanna? What does that simplify to? Write down as I write. See what I have up there? You should have that too. I'm going to let Johanna get it. Think about what number can you divide both of those by to get it smaller. What's the biggest number you can divide them by? What's the greatest common factor? That's a 6 on the top. It's an ugly 6, but it's a 6. Six. Nope. 1/6, which equals 1/6. Ooh. Then we have the probability of doing doubles again, right? Isn't that what we're trying to do? Doubles 2. I'm going to put a 2 there, just saying that that's the second time we're rolling. And it's going to be the same. It's going to be the same because it's still 6 out of 36, which is 1/6. Then we have the doubles of the third time. Dubs. 1, 2, 3. 1/6. 1/6. Dubs. I'm just making it faster. Now we have to do the probability of 3 doubles. Now when we look at the symbols above that you wrote, sorry, earphones users, I just want that to the microphone. You guys saw the written down? Okay. Look at the, we decided this is a independent variable because it doesn't change. If you roll a double the next time, it's not like you can't roll a double again. That's what we're trying to find out. So we have this written down right here. Okay? So what do we have to do? What's our probability of the first thing? What's the first thing? 3. Well, yeah, that's so. Yeah. We're looking for what's our one of our events that's happening. Roll. Yeah. So, but what's the first thing? Yeah, we have 3 events. What's the first event? Rolling a double. Rolling a double, right? 1/6, and we multiply them together because that's what it says in the notes above. We got to multiply each of the probabilities together. Excuse me. So the probability here's something wrong. Let's start the whole word again. Probability. of rolling 3 dubs is, I'm going to start circling this, because that will be the answer. I'm going to let you guys catch up so you can help me answer this. Okay, we're going to show you something. Come here. Come here. See where it says standard right there?
Yeah.
If you push this in and turn that, what it'll do is it'll hold your pencil, a number 2 pencil, exactly as tight as it's supposed to go, and it'll get it sharpened the first time. The more you know. What is 1/6 times 1/6 times 1/6? Well, first off, park review. How do I do this, Jace? Good. So you just multiply straight across that, you're saying? Yeah. 6 times 6 is 36 times 6, which is equal to what? 216. So the probability of rolling 3 doubles is 1 to 216. One to 216. So that was the independent one. That one was fácil. Esta una estaba fácil. Is that your hand up or you're just chilling? Okay. So that one was easy in Spanish. All right. Now, you guys have a little bit different layout on your printout than I did because I wanted to change your heading to fit. See how this is 6 in the upper corner? Yesterday we wrote 4. It was actually 5. This part that you guys have on your copy, that is actually right there, but just scribble over that. What I just said. All right, moving along. If you didn't hear me, you didn't hear me. Lunch bags are prepared for 50 students on a field trip. There are 3 different desserts in the bags. 20 contain a brownie, 15 contain chocolate chip, and 15 bags contain oatmeal raisin cookies. Favorite. The bags are arranged in random order. Connie and Steve were the first and second in line. What is the probability that Connie and Steve both select a bag containing the chocolate chip cookie? Both of them. Okay? So Connie's first in line. Let's find the easy one first. Connie's the first in line. So let's find the probability that Connie gets chocolate chip. Chocolate chip. That Connie gets chocolate chip. And to find probability, we need to find out exactly how many choices there are, or possibilities there are to get it. And then we do that over the total amount that there is. What is the probability that Connie gets chocolate chip? Yeah. 15 out of 50. So 15 50ths, because there's 15 chocolate chip out of total of students, or total bags. Okay? Now, Connie's a very hungry growing girl, but she's only allowed to eat one lunch, right? We're only allowing Connie to have one lunch. At the picnic, she was burning lots of calories, so she wants more. But then I was like, no. I know. So then, no. Then, now we have to do the probability of what? Probability of what? What is it, Harrison? The probability that Steve gets chocolate chip bag. So, how many chocolate chip lunch bags containing the chocolate chip cookie are left? How many are left, fellow? How many are left? There's only 14, yeah, because Connie She was very motivated, and she was first in line, and she got one. Okay? There's only 14 left, because a couple class periods ago, someone goes, hey, but how do we know that Connie gets it? It's like, well, we don't know, because what we're doing is we're trying to find the probability that Connie and Steve both select a bag containing chocolate. So in this situation, Connie got it, because we're finding the probability of both of them getting it. Okay? So we have 14 out of how many? So I'm referring back to this here. Okay, I'm referring back to that there. Whoa. Number of chances left and number of total left. We had 14 chances. How many are total left?
49.
There's only 49 left because Connie's over there munching down. Laughing at you as she's eating her chocolate cookie. Isn't it though? What pen am I using? There.
He didn't say slapping a person. He said laughing.
Laughing. But here's the thing. In my class, what do you always have to do? Simplify, reduce, reuse, and recycle.
Oh, you can do that.
So what can we reduce the Connie's chocolate chip thing to? Yeah. 3/10. Beautiful. 3 over 10. 3 to 10. What can we reduce that one to, Abby? 14/49. 2 over 7, correct. So in order to find the probability, zoom in again. I'm going to try to find the probability of both Connie, I'll just do abbreviations, Connie and Steve get the chocolate. What am I going to do next according to the symbols that we wrote above it? Isn't it right here? Oh, should have that. Isn't that it? Probability A times the probability B after A. Lots of blank faces. Yes? No? Should we just draw a picture of a horse head and that's it? Are we done? No. Help me out. What do I do? Yeah.
You do 3/10 multiplied by 2.
Yes. Yes, that's exactly it. Because you have to multiply. Yes, good. Thank you. I appreciate your confidence on that. Okay? 3/10 times 2/7 because here's the probability of event A. We're multiplying it by the probability of B after A happened. You guys are trying to end the assignment early and being like, I don't care about you.
That's not the song.
What song are you talking about? Right? Okay. So we are going to have the probability of this happening. We're just going to multiply straight across. It's going to be 6 over 70. And I know that that can reduce to...
I thought you guys could change the bottom numbers to be the same.
Nope, that is adding and subtracting fractions. Multiplying is the easiest one. You just multiply straight across. 3 over 35. That's the correct answer. Yes?
Can't you cross simplify?
You could cross simplify. You could cross simplify here. 1 and 35. Wait a second.
But 6 and 7.
6. Yeah, then it would be 6 over. Wait, I did the wrong. What am I doing here? This way. Then it would be just 3 times 1. Doom, 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 doom. I got a song stuck in my head. No, there's like 3 that sound so similar when it comes on. I'm like, is it that one? It's like, no.
Is it that fancy?
All right. So it's 3 over 35, and I'm going to go ahead and write it into words because its answer is in words. The probability There's words in the question, gotta have words in the answer. The probability of both Connie and Steve both getting chocolate chip.
What happened to Steve?
He's up there. Yeah, he is.
Connie and both. Oh, I almost left out Steve. Both getting chocolate chip dessert is, what is it, 3 35? 3 35ths. So loud. Good luck, guys. Where are you at today? Get 'em. Get 'em.
How many minutes do we have left?
A lot. He fixed it this morning.
So that's correct answer, 3 of 35. Now these ones are super easy. Super easy. So for the next one, it says here, write down whether each event is independent or dependent. Here's the situation. Roll a die, then spin a spinner. You can rewrite it again at the top. There's no work we have to do with this, so don't worry. Rolling a die, then spinning a spinner. Deja, what you think? Dependent or independent? What is it? Independent. You are correct. It is independent. It is independent because it doesn't matter what happens to the first event, or it doesn't matter what happens in the first event for the second one. How about this one? Drawing a marble from a bag, then drawing a second marble without replacing the first marble. Corey. Dependent. That one is dependent because without replacing the first marble, that's what makes it dependent. It changed. It's changed since the first situation, so it becomes dependent. Then, as team captain, you are selecting someone. Yeah.
So, like, if you're changing something, it's dependent, and if you're not changing anything, it's independent?
That's a really good way to look at it. Yeah, if you're not changing anything, if it's still the same situation where the same possibility flies, then you'll have it. So, as team captain, you are selecting someone to be on your basketball team when selecting a second player, or then selecting a second player. Max? It is dependent because are you going to be able to pick the same players? No. Dependent. 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 Now, just like on the homework tonight, this situation is going to reset with every new number. So this situation is independent of this one, which is independent of that one, so it's going to reset with each one. In a bag, there are 5 red marbles, 2 green marbles, 4 yellow marbles, and 3 blue marbles. Once each marble is drawn, it is not replaced. So what does this red flag tell us? Dependent. Beautiful. Dependent, because it changes. Find the probability of each outcome. 2 green marbles in a row. So we have to find first an answered phone call. The probability of drawing a green marble first is what? The probability of drawing a green marble first, Bello? 2 out of 14, because starting out, I'm going to use a different color. I'm tired of this one. The probability of rolling a green for the first one is going to be 2 out of 14, because there are 2 green marbles out of a total of 14. And we're going to reduce that to 1/7. Now, how about the probability of getting a green on the second draw? Sydney? What is it? Yeah, look. 2 marbles in a row. 2 green marbles in a row. Think about how many green marbles are left over how many marbles total. Nope. How many green marbles are in there? 2. Then we drew one of them, right? So how many's left? 1 out of how many marbles total? 1 out of 13. Yeah. So the probability of drawing 1 green marble and then the second green marble is going to be, from what we did before, 1/7 times 1/13. Boom. That is a green with a 1 apostrophe there next to it. So you can tell the difference, and there's green of the second one. So you can see that there's 2 different events going on. What is 7 times 13? Some of you might be able to do it really fast through distributive property if you do this. You don't have to write this necessarily. Seven times 10 is what? 7 times 3 is what? 100 plus 21, or 70 plus 21 is what? 91. So the probability of drawing 2 greens in a row is 1 to 91. 1 in 91. Can I what? And I can't reduce that, can I? No. Okay, let's do this one. How about a red and then a yellow? The probability of drawing a red and then drawing a yellow. Oh, it's not there anymore. What's the probability of drawing a red? Yeah. 5 out of 13, because we have 5 red marbles out of 14 marbles. You said 13 or 14? Should be 14, because it's number 1 is different than number 2. There's like a reset button at the end. Okay. Now, what is the probability of pulling a yellow 1 second, McLean or McGuire? Nine? There's only 9 marbles left in the bag? Nope. This is not 4 out of not 14. There isn't 14 anymore in there. We got a red in the first one. There you go. 4 out of 13. Yeah. Yes, I did. Thank you. Yeah.
Why is it 13 when you pull 5 out?
You didn't pull 5 out. Yeah, it's just the probability. It's not the odds. This isn't success and fail like odds. Okay? Oops. But we didn't do that at all up here. We didn't do that where I see why. Because this one here, you pulled 1 out. Don't confuse it with that. I mean, this is just how many are left. Think about this, what you wrote. Here, number of chances left and number of total left. Okay? You still had all those chances to get the yellow. So then we had the probability of red, then yellow, is going to be what? What am I going to do next? Yeah. 4 over 13. Then if I want to cross simplify, I can. I'm going to take 2 out of here. So I like to do smaller numbers. So I divided by 2. So I'm going to take 5 over 7 times 2 over 13. 10. There's the answer. Nope, you cannot reduce it. You're not going to find anything to go into 91. Questions? Okay. Your favorite thing to see on notes? Yeah.
So we don't have to write this in a word answer?
Yeah, we will, but I'm trying to get you guys some time to do your work. So I want to give you 10 minutes to do it, and that would mean that I have to end this video in 3 minutes. Now, to show me that you know how to do this, I want you to do number 4, and when you have an answer, whether it's right or wrong, I'll give you the homework. If anybody's watching this on YouTube, the notes are already on my website, and you can see the solution to it. Yeah, section 10.9 is over. Goodbye.
Bye.
Cheese fries?